2, 1.
Hi viewers, welcome back to Knowledge Grasper Physics channel KGP. Hope you all are safe and healthy in this pandemic situation. In previous videos we discussed about work power energy. Please watch them for better understanding. In previous videos, we discussed the detail about work. In today's video, we will discuss detail about energy. Energy is ability or capacity to do work. Its formula is force into displacement and its units is energy units is joule and erg. 1 joule equal to 10 to the power of 7 erg. So now let's discuss in detail about energy. First we will learn what is commercial units of energy. Commercial units of energy is 1 kilowatt hour. 1 kilowatt hour is electrical energy consumed by an electrical appliance at rate of 1 kilowatt in 1 hour. So this is example. For example, this bulb takes 1000 watts electrical energy in 1 hour, then it is 1 kilowatt per hour. Now next we will see what is dimensional formula of energy. So first, what is dimensional formula? Dimensional formulas are those powers of an physical quantity to which fundamental quantities are raised to express the physical quantity. The dimensional formula is used to express physical quantity in terms of dimensions. Means this physical quantity, in this case energy, is expressed in terms of fundamental quantities, means MLT. So let's see the derivation. Now formula of energy is force into displacement. Force is mass into acceleration. So mass into acceleration. Acceleration formula is meter per second square. So we will get the final answer as mass into meter square per second square. So in terms of MLT, the dimensional formula is ml square by t square in case of energy. Now we will discuss types of energy. Now we will discuss what is mechanical energy. The sum of kinetic energy and potential energy is mechanical energy, Ke plus Pe. So what is kinetic energy? What is potential energy? So energy possessed by an object with virtue of its motion, it is kinetic energy. So energy in virtue of motion is kinetic energy. So what is potential energy? Energy possessed by an object with virtue of its position, it is potential energy. Its formula is mgh. So kinetic energy is virtue of motion, formula half mv square, and potential energy is virtue of position, formula mgh. And this image is example. So potential energy is position. Here the boy is catching the arrow and aiming, and kinetic energy is motion. So here arrow is traveling. So I think you all clearly understood what is kinetic energy and potential energy with this example. So next, what is heat energy? Heat is a form of energy which transfers from one system to other system. Means heat flows from one system to other system. This image is example. So in this example, the vessel containing water is kept on heat. So heat is flowing from the fire to the vessel which contains water, and then water is forming water vapor. So here heat is transferred from one system to other system. So it's very simple. Next, what is sound energy? Sound is a form of energy which is produced by the bodies in state of vibration. Means sound is produced by state of vibration. It propagates in longitudinal waves. This image has longitudinal waves. So, sound energy transfers as longitudinal waves and causes sensation of hearing. So, next, let's discuss about light energy. Light is a form of invisible energy which causes sensation of vision. It propagates as electromagnetic waves. Means light is electromagnetic waves. It has electric waves and magnetic waves. Light causes sensation of vision. We can see if only light is present. So, these electromagnetic waves, light, causes sensation of vision. For example, light from the sun. Now, let's discuss about elastic potential energy. This is very interesting. When a body is stretched or compressed from its natural size and gains extra energy, the extra energy is elastic potential energy. This image is example. Here the spring is static in first spring, means it is normal. After we compress, means we do work on that spring, then it gets elastic potential energy. If we do work on any object, it gets energy. Here in this case it is elastic potential energy, and that energy is released by spring is stretched. So it happens, right? So here it does work and gains elastic potential energy, and then does work and lose elastic potential energy. Very simple, right? Next we will see few derivations. We all know the formula of kinetic energy is half mv square. Now here is another formula. Momentum formula is mass into velocity. So here is another derivation. Momentum is mass into velocity. So velocity will be momentum by mass. So we all know that the formula of kinetic energy is half mv square. So instead of v, we substituted momentum by mass. So we will get the final answer as kinetic energy equal to p square by 2m. So we can also write it as p square equal to ke into 2 masses, or momentum equal to under root ke into 2 masses. So here is derivation of another formula. Another formula of work is half mv square minus half mu square. Let us see the derivation of it. You all remember the motion chapter, right? What is third equation of motion? It is v square minus u square equal to 2as. So we substituted mass by 2 in on both sides. So m by 2 into v square minus u square equal to 2as into m by 2. So we will do this derivation and we will get the final answer as work equal to half mv square minus half mu square. Take a minute to look at this derivation. Now we will discuss what is interconversion of energies. Now there is law of energy. Energy can be neither be created not be destroyed. It only changes from one form to another. So here in this moving pendulum case, kinetic energy is changing into potential energy, and potential energy is again changing into kinetic energy. By this picture, we will determine that in a moving pendulum, at C and B points, means at highest points it has potential energy, and at moving points means at point A it has kinetic energy, and at intermediate positions means between A to C, B to C and A to B it has potential and kinetic energy. Here the potential and kinetic energies in interconvert. There are also other real life examples for interconversion of energy. For example, the electrical energy is converting into light energy in case of bulb. The sound energy is converting into electrical energy again into sound energy through speakers, etc. Now we will see another derivation. Now we all know that 1 kilowatt hour is 1000 watts into 1 hour. 1 hour is 60 minutes or 60 seconds. So 1 kilowatt hour will be 1000 watts into 3600 seconds. So watt seconds will be joule, because power into time will be work. So 36 into 10 to the power of 5 watt second will be 36 into 10 to the power of 5 joules. We can also write it as 3.6 into 10 to the power of 6 joule or 3.6 megajoule. That's all for today, viewers. Thanks for watching. Hope you understood the video. Link for notes PDF is in description. Please share and subscribe my channel. Please like and comment on the videos. Please give me suggestions and your opinions on the video by commenting. Thanks for watching. Have a great day.